So with passive transport, no energy is required. Okay, again, I choose to represent energy by a capital E with a circle around it, but whether you do or not, that's up to you. But with passive transport, there's no energy required to reach an equilibrium. Another word is balance across the membrane. So let's give some examples of how this happens. The first one we're going to talk about is diffusion. For this, I'm going to draw my membrane as one vertical line. And I'm going to say that a triangle equals compound X. And then this is outside of the cell, and this is the inside of the cell. And let's say outside the cell, I have 3 of these. And inside of the cell, I have 1. What I have created here is a concentration gradient. What that means is that we have one area, which is going to be the outside, with a higher density of compound X. And we say it's a higher density because over here we have 3, and over here inside the cell we just have 1. So what's going to happen here is that compound X, which is represented by this triangle, will diffuse across the membrane and we're going to add that this will occur down the concentration gradient. So let's talk about how this happens. One of these triangles, because we have an imbalance, there's no equilibrium right now, one of these, there's going to be some random molecular motion going on, but eventually it's going to cross over. And it's going to become triangle number 2 on the inside of the membrane. So I will cross this out because we no longer have a third triangle on the outside of the membrane because we had random molecular motion, which I abbreviate with RMM. So they're just going on their little way, and then one gets pretty close to the membrane, and it's like, oh, well, I need to be over here. I need to create an equilibrium. So then he crosses over the membrane. Doesn't need any help to do that, right? So it's going to be something that's probably small and non-polar, and boop, he crosses over the membrane. Now you have 2 on one side and 2 on the other. So what we've had happen here is that compound X, one of our triangles, diffused across our cell membrane. And it went down the concentration gradient because we go from 3 to 1 and make it even. Now we have 2 and 2. Now in green, I'm going to circle that we have 2 and 2. And now we can say that equilibrium has been reached. We've reached a balance. And this is a reason to celebrate. So we had compound X. Originally, there was a concentration gradient that we had to deal with because we had 3 on one side and only 1 on the other. But we had compound X, one of them diffused across the membrane down the concentration gradient from high to low. And then as a result, you have 2 on one side and 2 on the other, and equilibrium is reached. Hooray!